So now we're going to get into chapter 5, specifically with the ideal side of chapter 5, so ideal gas concepts. So first off, let's start with the formula for density of mixtures. So the density of mixture is just going to be a weighted average based on the mass composition of that mixture. So you just sum the mass fraction of that component times its density, and you end up getting a weighted average for the density of the mixture. And then, so ideal gas concepts, we have the ideal gas law, which is PV equals nRT. And in order to apply the ideal gas law, you first have to check to make sure that it is a valid assumption. So to check for ideality, what you'll do is calculate RT over P. And if RT over P is greater than 5 moles per liter, then you're good to assume ideal. And then that's for diatomic systems. And then all other gases, RT over P greater than 20 moles per liter, you're good to assume ideal. And then standard temperature and pressure. So at standard temperature and pressure, 1 mole occupies 22.4 cubic meters per mole, and this is the molar volume. Here, the V with the little hat, remember that's molar volume. And so 22.4 cubic meters per kilomole, 22.4 liters per mole, and 359 cubic feet per pound mole. So the number of moles in the system is just equal to V at standard temperature pressure over the molar volume. The actual volume is going to be equal to V at standard temperature and pressure times T over T at STP times P at STP over P. This is just derived from the ideal gas law, so let me just write that out for you. So P over PSTP times V over VSTP, and that's just our PV, equals N over N times R over R, those cancel out, times T over T at standard temperature pressure. So when you rearrange that, that's what you end up getting as you're solving for this V there. Now here there's just spelling this out. SCM is standard cubic meter, and then SCF is standard cubic foot.